So the amount is the principal times 1 plus the rate as a decimal all to the power of time. The PRT means the same thing as the last formula. Now, the difference between these is really important. This one will give you the total amount, right? Which means the principal plus interest. This formula only gives interest. So it's really important to realize how they both work. Because if you're working with simple interest and you're being asked how much do you pay in total, you have to add the answer back to the principal amount. But if you're using this formula, compound interest, they've already given you the total amount. You don't need to add it to the principal again because the principal is included in the way that they're calculating. Does anyone have a mathematical explanation as to why that's true? Why does this include the principal and this one doesn't? I did talk to, actually, I made a video last night, if anyone watched it, that actually did talk about this briefly. Does anyone watch my videos? Let's have a look. Is it the what? I think it was. I'm going to have a look and see if anyone looked at it. Your videos. Let's have a look. How many views did I get last night? Okay, 4 people. Okay, so 4 people should be able to give me the answer. Amrita? No, it's much simpler than that. No. Okay, let me just tell you. This one has 1 plus R, whereas this one only has R. This is because what this is doing is the original amount plus the rate. You times anything by 1 and you get itself, right? So if you're timesing, so here what we're doing is timesing P by 1.02, right? If it was 2%, we're timesing P by 1.02, but here we're timesing P by, whoops, geez, by 0.02. So see how this includes the principal, but this doesn't? That's why this gives you interest only, and this will give you the total amount. All right? Hopefully that's just helpful information.
If you just take out, if just the P R to the power of T, then would that be just the interest? Or does it not?
Yeah.
Yeah.
Yeah. Well, no, sorry, no, it doesn't work like that because you're compounding every year. So the thing is, the principal is going down each year. Actually, let me show you that in graph form. So when you are doing PRT, let's get rid of that. All right, so I'm going to show you what this looks like in graph form, right? If you're borrowing money and then you're paying it off over time, it's a linear graph, right? You borrow a certain amount of money and then you pay it off in equal installments over time and then it disappears. Make sense? With this is a graph that looks like that. So what you're doing is you're borrowing money and then it's changing over time. This is an exponential. That is a really terrible drawing, by the way. Sort of would look more like this. Right? So eventually you get to 0 and this is your starting point. But you see, you pay off more at the start, but then you're paying off anyway. It sort of, yeah, it does that. So graphically speaking, that's why they're a bit different, okay? Because this is being compounded every single year, whereas this is just compounded once at the start, calculated once at the start, and then it's a flat rate. So don't worry too much about that. What I do want you to worry about is the formula itself, which is over here. Oh, and I'm not actually showing this on the screen, am I? So let's just close the whiteboard, share the screen, and we'll go back here. Okay, so what we need to know is just the difference between them. Anytime you're doing compound interest, you're doing this. Anytime you're doing simple interest, you're doing this. Oh, sorry, there is one more thing I need to show you, which is one very slight difference. All right, so if I said, oh, I've got to do this again. So if I said that this is compound interest, this is growth, right? This is exponential growth. You can also have exponential decay where things fall over time. This might be when you buy a car and over time it's worth less. Does that make sense? Right? So what do you think might be the difference between growth and decay? A negative sign. That's exactly right. So let's say that I buy a car, right? So I'm going to buy a brand new car. Let me talk about my car. When I moved back to Australia, I bought a car for, how much did I spend on my car? Maybe this? Sounds about right. Okay. What is the average rate of a car depreciation in Australia? What is the average rate of a car depreciation in Australia? All right, let's have a look. Car depreciation is, doesn't want to tell me anything. No, I don't want that. All right, I'm just going to make something up. All right, I'm going to make it 5.1%. Okay, so I bought my car. When did I buy my car? 2000 and... No, no. Shut up. 2018. All right, I bought my car in 2018. I bought it for this much. Let's say it depreciates this much. So how much is my car worth now? This is just, why am I doing this? It's going to make me depressed. All right, 1 minus 0.051 to the power of how many years? 6. I bought it 6 years ago. So someone tell me how much my car is worth now. No. Won't be worth as much as I want it to be. What is it? Seriously? 7 what? 108.52. All right. 58. Okay. Well, there's no way that's right, by the way. My car is not worth that much money. That's not, whoops. Oh, it's definitely worth less than that. Yeah, I've clearly made up a stupid rate because my car is not worth that much money. That may have been true if it was a new car when I bought it, but it wasn't. So, things can depreciate over time, right? So when things go down, they are depreciating. That is not how you spell depreciate. There's not a double C in there. I can't write and speak at the same time. Depreciate. And when things go up in value, what are they doing? Appreciating, right? Appreciate. So they appreciate in value or depreciate in value. So we're looking at growth and decay.